Swayam Prabha. Digital India. Educated India.
Okay, so we the last session we left at this slide, and we motivated that there are some issues in cloud computing that do not go well with the IoT scenario, and volume, latency, and bandwidth being one of the few of those aspects that are really making it difficult with the increase in the number of connected devices. What is the solution to it? It is nothing but edge computing. Of course, one solution to it is that you keep increasing the data center size. But as you saw in one of the figures there, um, for the kind of for the number of devices in several billions, the amount of data that it generates needs about uh, several thousands of data sensors, right? So that is very costly in itself, and therefore there needs to be a different way to solve this problem. And one of the solutions that came up is this fog or edge computing. So we'll generally call it edge computing, and we will see there are various flavors of edge computing. How these different edge computing terminologies, the different kinds of edge computing that the classifications, we'll see how they are different. So edge computing is nothing but architecturally it is not a very complex thing, because you're what you're essentially trying to do is, instead of having this centralized node or the centralized data center that you have, instead of that you're trying to have some other set of nodes, not just one, but distributed in the space between the cloud and the end device. And you have several such nodes, and these nodes are going to be much more closer to the end device rather than how the current cloud is situated. So this is by definition, this is a distributed information technology architecture, where the client data, that is the data that is generated by the end device, is processed at the periphery of the network. So you're not coming to the core of the network where the cloud exists, but you're processing it at the periphery of the network, and if possible, very close to the source where it is originating. Yeah. Um, so one thing that definitely is problematic, as we also discussed in the last session, was although you're bringing all that, you're introducing new nodes, and which are closer to the originating end device, data originating end device. It These nodes are going to be less capable compared to the uh, compute capacity and different other kinds of capacity that the cloud would have. So that is one problem that we have with these edge nodes. But we have to see how we can very efficiently do things that we could do with the cloud, uh, while in remaining within the constraints of what the edge node provides. So the advantages, of course, by introducing these new nodes between the cloud and the end device, is that all the data that the sensors collect, um, they are very securely processed in real time. Right? Okay, so um, the reason it's considered to be more secure is because the chance of the data that is getting generated being tampered with, or being or the um, data being manipulated is very less, because you're consuming it, or you're working on it at a very closer location than the cloud. So there is the possibility or the probability of that data uh, getting into wrong hands is that much more lesser. So that's one uh, reason why it's also said that it is secure. So other important thing here is that it is done in real time, because now you're not you don't have to go all the way back to the cloud, do the processing and then come back. So that round trip time is really minimized to a large extent, and therefore the real time applications are served better by this kind of new infrastructure that we have. Okay, are there some questions? No. Okay. Yeah. So so what is the reason we find this need of edge computing? The problems that we saw in the cloud computing model, right? So one of the challenges was latency. So edge computing addresses that problem, as we just saw, by decreasing the latency in transmission, and um, I mean, so to say, even for processing, maybe it's not really decreasing the time for processing, because cloud may have a lot more processing resources than what an edge node would have. But in effect, if you see the transmission time is quite large, and that's why when you save on the transmission time, and with a minimal set of resources that you have on the edge, it would still be better to compute the process the data on the edge. But there are some trade-offs there. So that's something that we will have to consider while deciding whether the data needs to be, or whether the processing needs to be done on the edge or the cloud. So one important thing that needs to be remembered here is, even though we are putting edge nodes or fog nodes, let's say, within in between the space of the cloud and the end device, we are not eliminating the cloud. Yeah, so cloud will still remain. It is still there for a purpose of having a bigger picture of the set of bigger picture of the environment, and the set of nodes that are there, and the set of applications, the models, maybe if you're running some algorithms that are using machine learning and all that. So there are a lot of things that the cloud can still do, and therefore cloud does not go away. The only thing is, the burden of cloud doing everything is taken away, and a lot of it is now pushed towards the edge of the network, uh, to the edge nodes. So that's the main thing that you do, and thereby latency is diminished a lot, and uh, the amount of data that needs to be transmitted is reduced by large orders of magnitude, because currently it can also happen that you can do some very intelligent but um, not so expensive processing on the edge device, and come to a conclusion that not all of the data that is sensed by the various sensors, or the data that is communicated by the end device needs to be sent to the cloud. So there is an initial filtering that is employed in the end nodes, which make it very important, because it initially all the raw data was sent to the cloud, which now does not need to be sent, because that there is this intermediate node which will take care of it. Okay, so that is one advantage that also is brought about by the edge computing. Of course, the three issues that we saw in the cloud computing scenario was there was a large volume of data, bandwidth was an issue, and latency was an issue. So you see that latency is solved, the volume of data is handled by the intermediate node, and there is only a there is only a fraction of that data that is sent to the cloud, thereby reducing the transmission of data also. So these are the advantages that are brought about by introduction of the edge nodes. Uh, of course, it means that you are now supposed to have this additional set of nodes, and there needs to be mechanisms to manage these nodes. But the advantages outweigh the challenges that it brings with it, and therefore, although there are challenges, those challenges are being worked upon by the research community and industry as well. So that's something very good about edge computing, and also there are some open forums like Open Edge Consortium, which are trying to uh, come up with some standards in how these edge nodes need to be. So what needs to be the characteristics of edge node deployments, um, what kind of services they need to provide, and what kind of applications need to be considered. So the use cases, all of these things are worked upon by the Open Fog Consortium. That's something that you can actually go and look at if you're interested in what the Open Fog Consortium is doing. You can just go and look at it. Their website things are available. A lot of white papers and all are available. So there are other consortiums also which work in this area. We'll get into one of them briefly in one of the slides later. So um, so edge computing is one very general term of this kind of a model where you are now distributing the computing across multiple nodes, and it's not centralized in the cloud, but there are different ways of doing this, and there are three models that are there that represent the edge computing paradigm. One of them is called fog computing. Then there is something called mobile edge computing, And there is also a model that's called cloudlet. Um, so all of these have they are relevant in certain scenarios, but you can see that all of them try to limit the bandwidth, limit the latency requirements, and try to minimize the network congestion. So if you look at it, the characteristics of edge computing, there are so some of these aspects that we looked at, that it tries to do better in comparison to cloud computing, feature here. So you can see that there is lower pressure on bandwidth. So the bandwidth between the edge of the network and the core of the network where the cloud resides is reduced dramatically by bringing in these set of edge nodes or fog nodes, and that is a very important aspect, also because you don't have to now transmit that much data, and that also reduces the cost of data transmission. So it's not only the congestion aspect due to limited bandwidth resources that are available, but also the cost associated with transmitting that this amount of data, that's also reduced. uh, and of course the latency is a very important aspect, because as I mentioned in the session in the morning, a lot of applications, they require uh, they have stringent timing constraints, and in order to satisfy the real time requirements, that's one of the issues that needs to be solved, which was an issue with the cloud computing model. um, then also one thing that we discussed earlier was the data security part. So how does edge computing, how does it provide better security than cloud computing? So this was something that we touched upon earlier, that since things are now more distributed, and since these nodes are much more closer to the end devices, um, an attack, the chances of an attack are are lesser, because you're not sending the data all the way to the cloud, and uh, there are the data resides in a more localized scenario. Thereby it is much more easier to employ some security mechanisms. Also the distributed nature gives it a little bit more resilience to security attacks, because the attack on one of the nodes may not result in propagation of their propagation effect to other nodes. So that way also it is there can be some things that can be avoided in the edge computing scenario in comparison to the cloud computing model. And finally, there is increased availability, because now you have the set of distributed nodes, um, instead of a centralized compute node. Although centralized node is also a set of nodes, but it's not centralized, it is more distributed. So even if a particular node in the edge computing model goes down due to some reason, it still can function, because there are other nodes which are the end device can still access some other edge node which is in the coverage area of the uh, in the coverage region. So that's why it's there is some increased availability that is observed. And all of these make edge computing uh, a very good solution to solve all the issues that we had with cloud computing. Of course, with I mean, this comes with some issues, and we need to also handle those issues, right? Okay, so the we'll look at fog computing and what fog computing is, but the fog computing platform, this is a template platform that fog computing nodes typically implement, and there are a set of aspects that are required to be there in a fog computing platform, which kind of addresses a lot of um, requirements that people, the end devices or end users may have. Okay, so there are some things that need to be available within the fog node to serve the requirements of the user. And towards that, there you can see there are some platform services that are there within the fog computing node. And these platform services, let's go through them briefly one by one. So there is an authentication authorization service. So it is ensured that every access to the fog node is done only by authorized users, so that there is no malicious user that present and trying to attack the node. Okay, so that is there is a security mechanism that fog node needs to support. There are different kinds of services that a fog node may provide. Typically, every end device may have a different set of services that it wants. For example, it may, for some end devices, it may be to download a set of you know download the map of a particular region. Let's say you're moving with your mobile, and you want to download the map of a particular region. In that case, the service that it requires is this downloading of the map. There may be different kinds of such services, maybe the uh, listing the set of restaurants in a place. So if a person wants person carrying a mobile device wants that kind of service, it can request that service from a fog node. And the fog node, if it has that service in the platform, then it provides the required information back to the mobile device. So when there are different kinds of services, you need to manage these services properly. And service management is one of the functionalities that is part of the platform services. Then there is functionality called or a block which is called the cloud agent. Typically, as I already mentioned, a fog node is not a node which is sitting isolated from the rest of the infrastructure, right? So the cloud is, and as I already mentioned, cloud is still a part of the whole hierarchy. There is some communication that needs to happen with the cloud, and this thing is initiated by the cloud agent. So if anything, if there is any communication that needs to be done with the cloud, that happens, that particular communication is initiated by the cloud agent. Then there are some location services. So one of them, as I mentioned, is the part where, let's say, you're going to a place and you want to know what are the um, one example I mentioned is what are the restaurants that are there in that place. So that is a location based service. There can be various such other things, like what if you want to look at a particular kind of um, garment shop in a particular region. So some similar kind of location based service. If you want location based services like this, that's also something that is part of the platform services. um, One important thing that I would like to point out here is there is something called as the offloading management, and this is a very crucial feature within and crucial functionality that a frog node needs to have. This is what that decides how the how a particular functionality or a service needs to be executed for an end device. So, for example, let's say I want to execute um, um, a function. Let me just call it a function X. I just want to execute a function X. Now, there is a way where I could execute the entire function X on my end device itself. Or if the end device is not capable enough to do that, then I could send that function to the fog node here. Yeah, so the fog platform here could allocate resources. So before I get into that, you can see here that there are these different VMs, right? The virtual machines. So even in fog nodes, you would have different VMs, and basically apps can be given resources on these VMs, and they can execute there. Now, if there is a service that or function that needs to be executed on the fog node, there will be some resources allocated here, and they will execute it. Now, it could so happen that the because of the resource constraints on the fog node, it might not be possible to entirely execute them on the fog node. So in that case, there needs to be a way to offload a part of this functionality to the cloud. And you could execute a part of it on the fog node, but some other part which even if so there could be several parts in a function where some of it may be critical to so that the data is available soon, but some part of it may be for a longer term, and therefore you don't need to get the results as soon as you want, as soon as the first part requires. So in that case, then there needs to be some management done where some part of it is kept here and some part of it is sent to the cloud, and that is what the offloading management does. So this is something very crucial in a fog computing platform, because you are not entirely discarding the cloud. You're still using the cloud for some very special purposes. So and then you typically have a communication service where which allows you to send data or communicate data with various kinds of devices. It could be a sensor node, or it could be some device which itself has some hardware and OS and applications running on top of it, like the laptop and the mobile device and so on. So it could be communicating with various kinds of devices, and this communication service is handling that. And there are certain set of APIs which are available, which um, access the underlying layers. You Some of the functionalities that are there in the underlying layer are things like load balancing, virtual machine scheduling, network management, system monitor. So if you want, so there are multiple things, multiple functionalities that are executing on the upper layers here. If you want to balance the load across, multiple set of nodes or VMs that are there, so there needs to be some load balancing algorithm that's there, and that will take care that it's not the functionalities are not mapped to a specific set of resources that are there. So also there are various virtual machine scheduling algorithms that are available, which can also be used based on what kind of uh, output requirements you have. um, of course, the network needs to be there is some network management that needs to be done, and your system needs to be monitored to see if the resources are being if there are resources that are not being utilized efficiently, or are there some resources which are being utilized more than what it should. So there are various kinds of things that functionalities that are built into this, and that is running quite very very close to the hardware layer above the virtualization layer. So a fog computing platform typically looks like this, and you have these different layers, and within these layers you have these functionalities that a fog computing node ought to provide. Um, so apart from that, I think this picture is kind of self-explanatory. So uh, it's just showing you the hierarchy where there are these end nodes available, and they are communicating to the fog node, and via the fog node to the cloud node, based on whatever is required from the cloud. Yeah. So it of course it could so also happen that the end nodes are directly communicating with the cloud node for some specific purposes. So that communication is still there, but some of the major computation functionalities are first handled by the fog node, and then uh, some remaining part may be sent to the cloud. Okay, or some data might be filtered at the fog node, and then the remaining data may be sent to the cloud. So one of these things would happen. Okay, so having looked at that, and before going into the different models of different models of edge computing, let us look at an example to see the potential of edge computing. Yeah, and what better example can you have than if you can provide some efficiency in the healthcare industry, right? This is something that is very crucial in various ways, and it has its age of the population, that is criteria that needs to be looked at. The emergency with which you address the requirements of patient, that is also one of the issues that you need to very carefully address. So So there are multiple aspects with the healthcare industry, and the applications associated with the healthcare industry, and edge computing plays a part in that. So you can see here there are three different scenarios that are shown. Um, so that one of the scenarios that you could have. I'll go to the details of these scenarios in the subsequent slides, but to just show you, there are multiple locations where you can have the edges, and it plays its own part. Yeah, so you could have a device that is sitting at that a patient has at home, which could provide remote monitoring and care, and that device takes some crucial decisions, or monitors crucial decisions may not be taken at the device itself, but it may monitor data and provide data in time, so that the healthcare expert can then come back with what needs to be done. That is one way of using the edge, but still that edge device has to execute some functionality. Okay, so that device sitting in your house. Then there are on-premise edges, which means edge nodes, which are in the healthcare premises, hospital premises. Yeah, so it would have. So there are multiple devices that you see in hospitals, which are used for patient monitoring. These are the on-premise edge devices. And then there are devices that you could have in a connected ambulance. Yeah, so that's going into the realm of an edge device, which is not static, right? So you are, in this case, your connected ambulance is moving, but still it is something very important. We'll see why. Okay, so there are different types of edge devices, of course, but it also is important where that edge device is. So the location of the edge device is important, and based on that, it does some functionality that is suitable to be executed in such platforms. Um, and uh, and of course, I mean, this spectrum is just showing you the horizontal axis is just showing you where the execution is happening, the workload is being processed. So in this case, it's the end device. In this case, it could be the enterprise solution that you have with, or an access point is there, where you could send the data to the access network, and then to the cloud probably. um, and here you're basically having the mobile node. So there is some transportation that's involved, and the mobile node may be communicating with another fog node, or it could be communicating with the cloud of that cloud, where cloud of the particular hospital that then sends data to the healthcare experts. Okay, so there are multiple points where these edge nodes can be deployed. That's the main aspect, or the main carried main takeaway aspect from this slide here. Okay, so let's look at these things a little bit more closely. So as I mentioned, the connected ambulance. Um, so one of the things that definitely is required, which kind of lacks in the current scenario, is that your ambulance is not equipped with the capability of monitoring the patient, and at the same time sending the crucial vital informations or vital statistics of the patient to the healthcare expert. So uh, as until the ambulance is reaches the hospital premises, the healthcare experts are not aware of what is the patient situation. Okay, so that is one aspect that the connected ambulance tries to do. It keeps it has all the monitoring equipment. There are some diagnostics that are done, and by the time the patient reaches the hospital, those very vital data are already available with the healthcare experts, and they can be ready with what needs to be done, or they can do an initial um, analysis of what the situation is, and be ready with what needs to be done by the time the patient arrives, because there is this time between taking the patient from the home to the hospital, which is crucial time often. And so there if things can be done better during that time, that always is going to improve the chances of saving the patient. So that is one thing. But one of the things that we already saw what edge computing provides is low latency, right? So here we do want things to happen. We do want things to be processed fast and sent, right? So low latency. In this case, we also want mobility support, right? So the node is not static at one place; it is moving around in the environment. So when it is moving around in the environment, whatever services it needs should still be available to it. The movement should not be factor that causes the availability of service not to happen. Yeah. So mobility support is one thing that is crucial here, and the some initial processing or some monitoring and processing that's done should be the ambulance connected ambulance should be able to do that with sufficient resources. May not be too much resources, but some amount of resources to do that initial processing. Okay, and then you can send the data over the network, and that can help the health experts to make their diagnosis and be ready with the treatment as soon as the patient arrives. So it could also be that you want to do some live streaming of processed patient data. Yeah, so that's something that also this could enable. Um, and and as I said, the analysis part is made more effective by doing this. And you could have at the edge itself some real time diagnosis, and some diagnostic tools can be used to understand the situation of the patient. So all these kinds of possibilities are there, and this is there within the realm of a mobile node, which is traveling in the environment. So that's a moving edge node, so to say. Of course, after the patient comes in the hospital, the the patient is monitored continuously, and the monitoring devices now are so some you can see that in some situations these devices are standalone, they are not connected, or these are connected, and they are the data, that is the large amount of data that's collected, um, uh, I mean is either processed and then sent to a third party cloud, or you send the unprocessed data entirely the raw data to the third party cloud. Yeah. So this is for a long term purpose, right? You're monitoring this data and you're keeping a record of this data. So this is a long term reason why you want this kind of data. But one of the concerns here is that you don't want the data to be available um, with parties who want to utilize such health related data. Yeah, so some security issues are there and some privacy concerns are also there. So that needs to be handled. And if you the best way of handling that is if you have a private cloud on the hospital premise. So there could be an on-premise edge in the hospital that locally maintains the data. Therefore, providing for privacy and whatever compliance is necessary. And uh, the of course the other thing is that this kind of connected setup in an in hospital inside hospital will make it easier for the clinicians, and their productivity also increases because now data is available um, for them to go through quickly, right? So that is definitely one case of edge devices processing and providing the required information. And finally, we have this other extreme where you're looking at a remote monitoring and care situation. The elderly population, um, they or even some population which is uh, who can have some emergency situations. If they want to be monitored closely, then this kind of remote patient monitoring based on edge devices could be a very good solution, because then the healthcare workers can be getting constant updates on what is the situation of the patient. um, of course, I mean, these are again there are again privacy issues if you run these applications in the cloud, and therefore it makes sense to run them on edge devices. Sensitive data is protected by doing this. There could be some initial very minimal processing also to be done to generate some alarm signals based on the conditions of the patient, and that could be low. It typically needs to be a low latency one if it's a really serious alarm condition, and there again the edge helps. And the of course the amount of data that needs to be sent based on the uh, kind of monitoring that is done could also strain and lead to higher costs, strain the bandwidth and lead to higher costs, which can be avoided by using the edge device. Yeah. So you can see the different places and locations where edge device plays an important role, and at each place it's a different uh, role that it plays. So there is some initial care that it plays when it gives when it's doing the remote monitoring. Then there is some intermediate care that it provides when it's in the ambulance situation, and then there is this final place inside the hospital where you are constantly monitored and taken care of, right? So there are these various locations where it comes to use. So having looked at that application, that kind of gives a really good view into what fog computing is, or what edge computing is, but what the various models could look like. So fog computing, this terminology of fog came into existence. Um, you know, uh, it's kind of a metaphor, because you see that there is this cloud-like fog that is very close to the ground, right? So basically, that's close to the ground is kind of a similarity that you have for node which is close to the end device, or which is at the edge of the network. So that's why this fog computing terminology came about.